So here is question number 21 everyone. Two soap bubbles with radius 3 cm and 4 cm coalesce in vacuum under the isothermal condition to form a bigger bubble. The radius of bigger bubble will be what? Now first of all, the surface energy of the system will always be constant, since surface energy will be conserved. Therefore, surface energy of system initially will be equal to surface energy of system finally. Tension into area is surface energy T into 4 pi r square plus T into 4 pi another r square equals T into 4 pi bigger r square. T4 pi, T4 pi, T4 pi cancel out. We will get the value of r, therefore 5 centimeter. Option number 3 is absolutely correct. We will go with option number 3 only. Move on to the next, that is 22 number. So here is question number 22 everyone. Magnetic susceptibility of paramagnetic substances at minus 123 degrees centigrade is 2 into 10 power minus 2. Then its value at minus 73 degrees centigrade will be what? We know very well that the magnetic susceptibility of paramagnetic substance is inversely proportional to absolute temperature. Therefore, we can write chi1 upon chi2 equals T2 upon T1. Putting the values, chi1 that is 2 into 10 to the power minus 2 upon chi2, which we have to find. T2 is minus 73. In Kelvin it will be 200. T1 minus 123. In Kelvin it will be 150. After solving, we will get the value of chi2 as 1.5 into 10 to the power minus 2. Option number 1 absolutely correct. So therefore we will go with option number 1 only. Now move on to the next, that is 23 number. So question number 23 students. Volume of 1 mole of an ideal gas expands with temperature according to the relation V equals kT to the power 1 by 3, where K is constant. If the temperature is increased by 45 Kelvin, then work done by the gas will be. Symbols have their usual meaning and all quantities are in SI system. The relation given V equals kT to the power 1 by 3. Let us differentiate. We will get dV equals what? K T to the power 1 by 3. So 1 by 3 T to the power 1 by 3 minus 1 dt. Now dV can be written as 1 by 3 K. This can be further written as T to the power 1 by 3 into T to the power minus 1 dt. This particular thing is what? V. So we'll have dV upon V equals 1 by 3 T dt. This relation we have got. Now this is 1 mole substance, so PV equal to RT from the ideal gas equation. We will have the value of P from here, that is RT upon V. Now we can have the work done W, that is integration of P dV. Now putting the value of P, we have P as RT by V multiplied by dV, that is V upon 3T into dt. VV cancel out, TT cancel out. What do we have? Within the integration R by 3 dt, that is work done. Now total work done will be what? R by 3 constant comes out of the integration dt. Integration of dt is what? Total change in temperature, total increase in temperature, that is 45. So R by 3 into 45. We will have the value of work done, that is 15 times R. So this is our final answer. Option number 2 absolutely correct. Now move on to the next, that is 24 number. So here is question number 24 everyone. An amplitude modulated signal SAM is given by SM equals 20 sine 10 to the power 6 pi t 5 cos 999 into 10 power 3 pi t minus 5 cos 1001 into 10 power 3 pi t, where t is in second. The bandwidth of the signal will be what? We know very well that the bandwidth is given by 2 into frequency of modulated wave, 2 FM. In order to calculate bandwidth, we require this FM. We know the equation for amplitude modulated signal, that is SAM, given by AC sine omega ct carrier wave plus AC times mu by 2 within the bracket cos omega c minus omega mt minus cos omega c plus omega mt. Now let us compare this standard equation with the given equation. What we will get here, 999 and 1001 can be written as 1000 minus 1 10 to the power 3 pi t, and similarly 1001 can be written 1000 plus 1 into 10 to the power 3 pi t. So this can be omega c, this can be omega m, this can be omega c, this can be omega m. We have got the value of omega m, therefore that is 10 to the power 3 pi, and omega is equal to 2 pi f. So 2 pi fm we have got 10 to the power 3 pi, pi cancel, frequency of modulated wave, that is 10 to the power 3 by 2 hertz. Now bandwidth will be what? 2 fm, that is 10 to the power 3 hertz or 1 kilohertz. Option number 2 is absolutely correct. We will go with this particular option. Now move on to the next, that is 25 number. Here we have question number 25, everyone. Two concentric conducting spherical shells of radius r and 2r carry charges minus 2q and 3q respectively. If both shells are connected by a conducting wire, then magnitude of charge flown through the wire will be what? So now let us try to solve it. Outer one 3q charge, inner one minus 2q charge. If they will be connected through a conducting wire, what will happen? Charge will flow, say from this to this. So the net charge at outer one will be now 3q minus q, and the inner one will be now minus 2q plus q after connecting them with the wire. Outer one B, inner one A. Since they are connected with conducting wire, the charge flow will take place until their potential becomes equal. So VA barabar VB. Now let us write the expression for VA and VB separately. VA given by K, charge is minus 2q plus q upon R. This is due to sphere A, but here is a charge sphere B also. So plus K times 3q minus q upon 2R. Equation number 1. Similarly, VB can be written as potential due to outer one plus potential due to inner one. K times 3q minus q by 2R plus K times minus 2q plus q divided by 2R. Taking it as equation number 2. Now, since V and VB both are equal, if we equate them, this K term will be cancelled out, and what we will get? We will get minus 2q plus q divided by R plus 3q minus q divided by 2R equals 3q minus q divided by 2R plus minus 2q plus q divided by 2R. R will also be cancel out. This 2 will also cancel out, but here will be another 2. After solving, what we will get? We will get 4q plus 3q minus 3q plus 2q equals minus of q. Therefore, minus 2q equals minus q. Q will be finally 2q. It means capital 2q amount of charge will flow from outer one to inner one. So option number 3 is absolutely correct. We will go for option number 3 only. Now move on to the next, that is 26 number.